Okay, AP Calc. We are going to take a short quiz tomorrow over this new volume stuff. So I haven't heard from a lot of you, but I'm hoping that you all have been ideally spending the time watching all the videos the last 2 days, doing the homework. I'm sure it helps that the answers are at the end of the homework. So both of those worksheets, if you keep scrolling, the answer key and solutions, all the work and the picture is right there to help you. But I'm going to get after this, I will just email you with individual responses if you have questions about certain problems in order to be ready for tomorrow's quiz. I have heard from a few of you, and one really good question I liked was someone asked, how do you know whether to do the X or the Y axis on a problem? And that is a great question because when we were doing area, you did have to ask yourself, are you doing X or Y? Are you going to integrate in terms of X or Y? It didn't have anything to do with the axes then. It was just, am I going to do this in terms of X or am I going to do this in terms of Y? Okay, this is totally different than that because you're not just deciding X or Y, you're deciding which axis to rotate. And actually, back up, you're not deciding at all. How do you know whether to do X or Y axis? You don't make that decision. That is always going to be clarified in the directions. Okay, you don't get to pick which axis you rotate a bounded area around. That is something that will always be specified in the directions. Okay, so I'm going to do a few. I'm going to go in order. This is from the first worksheet. So this was before you even knew about rotating around the y-axis. Okay, so this problem here, the directions did say rotate it around the x-axis. So this one would create a disk. And what's going to be very important for you to know by tomorrow is whether you have a disk or a washer. And I've said it before, I'll say it again. The way you tell that is you have to ask, is your bounded area snug up against the axis you're rotating around? If it is, like it is right here, right against, there's no gap. It's right against the axis you're rotating around. You're not going to have any sort of hollow three-dimensional figure. You'll have this, completely solid, dense figure, no washer, just discs that you're adding up. Okay, so another key piece that I already have the work done for is the picture. You have to be able to draw an accurate picture of this if you're going to do the problem. I think all of you could do this if I gave you the picture. So I have the picture drawn, which is what you would need to do, and that's how I know this is going to be a disk, and that's again because it's snug up against the x-axis that I'm rotating around. Technically, it's disks that we're adding up. The volume for these disks is pi r squared times h. But since we're doing, again, multiple disks, it's pi with an integral r squared h. And the integral is what makes me add up all these different disks. Okay, well, then specific to this problem, that would be volume equals pi. And I'm going to do this around the x-axis, so it's -5 to -4 is what it looks like. The radius of each of these disks after it rotates around, so this one's kind of really small, but the radius of each of those disks is just the function. So the square root of x plus 6 squared. And then the height of each of those disks, and remember, okay, so if I were to draw one of those disks over here, the height of each of those disks is actually, what we would rather call when it's turned like this, the base. But that is the height right there. So the height of that is dx. The height is dx. So you would plug that into your calculator and you should get 4.71 approximately. Okay, so then how does this problem differ from number 12 on the same worksheet? Well, okay, again, back to that whole idea that if I'm going to rotate this around the x-axis, it's going to not be touching the x-axis the entire interval of integration. Okay, this is not snug up against the x-axis. So this is how we know we're going to be adding up an infinite number of washers. Now, washers and disks are very similar. They have the whole pi r squared h idea, except for a washer, it is pi, and r squared is it's not just one thing. It's going to have to be, I'm going to go ahead and do r sub t. What do you think that's for? R sub top is what I'm calling that, the top function, minus r sub the bottom function, and then times the height. Well, specifically for this problem, that would be pi. And we're going to go from x equals 0 to x equals 4. The top function is the square root of x plus 4. I'm going to square that, another parenthesis, minus the bottom function, which is y equals 4 squared, or y equals 4, and then I'm going to square it, and then times the height. The height of each of these washers is dx. So you would then plug that into your calculator. Okay, the last one I wanted to go over, this is actually one I've heard about, and I realized this would be really hard to graph, and I probably wouldn't put this on a quiz. But okay, so right now, what I have graphed is, so ignore the fact that that says x-axis and y-axis. I actually turned it on its side. This is what let's see, I think it's y equals 2 secant looks like, okay? Y equals 2 secant of x looks like. Okay, so as soon as it's x equals 2 secant of y, we just take this, need to erase all this now, and we're just going to turn it on its side. There's this thing, there it is. Okay, so that's what x equals 2 secant of y looks like. Okay, amplitude of 2. Okay, so if we're going to do this in terms of y, I do want you to recognize that this is going to again be disks that we're adding up. And the reason that I know that is because for the entire interval of integration, limit, it is snug right here up against the y-axis the entire time. So as this does, create these disks and start wrapping around, it's going to be right up against, so that's not going to be hollow at all. The whole time it'll be solid. So we have pi, and now this time, since we're doing the y-axis, these need to be y values. So it goes from negative pi over 3, and that is spelled out, that's what those horizontal lines are, and that's in the direction. So negative pi over 3 to pi over 6. Okay, and then my radius is going to be 2 secant of y. The x value, 2 secant of y. And then my height is the change in y, dy. Whoa, that's a weird y, sorry. Okay, so then you plug that into your calculator and you should get 29.021. Okay, so that's all I have for now. Please email me so you're ready to take a quiz tomorrow.